Okay, we're now going to look at putting all this together. So equations of medians, perpendicular bisectors and altitudes, we're going to look at them together and see how they intersect with each other and find points of intersection of different straight lines. Now, just to recap, remember that medians, altitudes and perpendicular bisectors are all straight lines. Since they're all straight lines, you need a point and you need the gradient. So you need a point that lies on the line and you need the gradient. And you would sub that into y minus b equals n bracket x minus a, where a point is labelled AB. Now, just to recap as to what each straight line is, the first one we looked at was a perpendicular bisector. Okay, so let's say that that's triangle ABC. Well, the perpendicular bisector of AB, well, first of all, it bisects the line, so that means that it cuts it in the middle, denoted by these two pairs of lines, and it cuts it at a right angle. So there would be the perpendicular bisector. Now, the thing to be sure on is that perpendicular bisectors do not come from a vertex. If you want to get the point for a perpendicular bisector, you'll get it from the midpoint, okay? And each triangle, or every triangle, has got three perpendicular bisectors. So here's a second one, which is the perpendicular bisector of BC. Again, cuts at a right angle. And then finally, here's the perpendicular bisector of AC, cuts it in the middle and cuts it at a right angle. Okay, so that's perpendicular bisectors. Next one we looked at was altitudes. Okay, so another triangle ABC. Okay, so an altitude again is a straight line. Now, an altitude is a straight line that comes from a vertex and cuts the opposite line at a right angle. So, for example, if I was looking for the altitude that came from B there, it would cut this opposite line at a right angle. It doesn't cut at midpoint, that's not the description of the line. It comes from a vertex and it cuts at a right angle. And just like perpendicular bisectors, altitudes, there's three altitudes in every triangle. Then finally we've got medians. Okay, so another triangle ABC. Okay, so medians are straight lines. Medians are straight lines that come from a vertex and cut the opposite line in the middle. Now this time it's got nothing to do with right angles because that's not part of the description. A median is a straight line that comes from a vertex, comes from a corner and cuts an opposite line in the middle. And just like perpendicular bisectors and altitudes, each and every triangle will have three medians. So remember, it's all about getting a point that lies on the line, the gradient of the line, subbing into y minus b equals n bracket x minus a. So for perpendicular bisectors, how do you get the point and gradient? Well, you get the point from the midpoint. How do you get the gradient? Well, you get the gradient of this line and then you do the flip and invert to get the gradient of the perpendicular bisector. For an altitude, how do you get the point? Well, the point's dead easy. It comes from the vertex, it comes from a point, so you use that as a point. And how do you get the gradient? Well, you find the gradient of the opposite line and again flip and invert m1 m2 equals minus 1 to get the gradient of the altitude. What about the median? Well, it comes from a point, so that can be used as the point. How do you get the gradient? Well, you will need a second point, which is the midpoint here. And then you do y2 minus y1 over x2 minus x1 to get the gradient. Once you get the gradient, you've got a choice of 2 points. You've got that point that lies in the line, that point that lies in the line, so you just choose one of them. It doesn't matter which, you'll get the same answer. And you take the gradient and take one of the points that you've chosen and put it into y minus b equals n bracket x minus a. Okay, that's an overview, and let's start to put these together and look for some points of intersection. Okay, so this example says f, g and h are the points 1, 0, minus 4, 3 and 0, minus 1 respectively in this triangle. Fj, which is denoted by the green line, is a median of the triangle FGH, and h are denoted by the red line as an altitude. Find the coordinates of the point intersection of D. Okay, so the point intersection, we're calling that D. So that's just there. Okay, so it's the point intersection of the two straight lines FJ and HR. Okay, well, the first thing that I'll need to do is to find the equation of both lines. So I'm first of all going to concentrate on the altitude. That's the one marked in red. So I'm just going to head that up with a heading altitude. Okay, so remember that an altitude's a straight line, so I need point and gradient. Now, what's the point? Well, remember the altitude's the red line. Well, I can use this point here. So there's my point. So I'm just going to mark that as the point, 0, -1, and that's then labelled as AB. I'm now going to go after the gradient. So how will I get the gradient? Well, I'm going to have to find the gradient of this line and then do the M1, M2 equals -1. That's the flip and invert bit to get the gradient of the altitude. Okay, so first of all, it's going to be the gradient of GF. So that's going to be y2 minus y1 over x2 minus x1. So that's going to be 0 minus 3 over 1 minus 4. Okay, so that's minus 3 over 1 minus 4 is 1 plus 4, that's 5. Okay, so then I need to explicitly write m1, m2 equals -1. And then flip and invert, and that will become positive 5 over 3. So the gradient then of the altitude is positive 5 over 3. Okay, so I'm now ready to put that into y minus b equals m bracket x minus a. So a is 0, b is -1, and the gradient m is 5/3, so that's going to be y minus -1 equals 5/3 bracket x minus 0. Okay, I'm now going to take the opportunity to get rid of this fraction, so the divide by 3 bit, I'm going to eliminate that by multiplying both sides of the equation by 3. So that will be y plus 1 equals 5/3 bracket x minus 3. Okay, so multiply both sides by 3, 3y plus 3 equals, times by 3 cancels that out and just gives me 5 bracket x minus 0. 3y plus 3 is equal to, let's open that up, and that will just be 5x. I'm going to bring that across to the other side now, change its sign and leave it as 5x minus 3. Okay, so that's the equation of the altitude. Now let's concentrate on the equation of the median. Okay, so the median is the one that's marked in green. Okay, so I need point and gradient. Okay, so I've got a point here, so I'm just going to immediately say that that's the one that I'm going to use, even though I'm going to find a second point later on. So the point is 1, 0, that's AB. Now I go after the gradient. So it's the gradient of the median here. So how do I get the gradient of the median? Well, I'll need a second point, which is the midpoint. Okay, so I need this point J, and I'll need to use the midpoint formula. So that's x1 plus x2 over 2. Don't mix it up with the gradient formula, it's completely different, and y1 plus y2 over 2. Okay, so it's the midpoint of, let's be sure we know, it's the midpoint of this line. So it's going to be x1 plus x2 over 2. So it's -4 plus 0 over 2. And y1 plus y2 over 2, that will be 3 plus -1. Well, I can just write that as 3 minus 1. Over 2, -4 plus 0 is -4, -4 over 2 is -2, 3 minus 1 is 2, 2 over 2 is 1, so that point is -2, 1. Okay, so my next move then is to find the gradient of the line. So it's going to be y2 minus y1 over x2 minus x1. Okay, so that's going to be 0 minus 1 over 1 minus 2. And that's -1 over 3. Now there's no need to do m1, m2 equals -1 here, because that is the gradient of the green line. That's the one I'm looking for. It's definitely got a gradient of -1/3. Okay, so now into y minus b equals m bracket x minus a. Now there's 2 points that lie on the line that I can use, this one or this one. I've already decided to go with this one. You can go with this one, it's not a problem. But I've already decided to call this one AB, so that's what I'm going to go for. Okay, so it's going to be y minus 0 equals the gradient minus 1/3 bracket x minus a, which is 1. Okay, I'm going to take the opportunity to get rid of the divide by 3 by multiplying through by 3. So that's 3y, well, it's going to be still 0, so I'm just going to eliminate that. So that's just 3y equals minus 1 bracket x minus 1. Open it up, 3y equals minus 1x, that's minus x, and minus 1 times minus 1 is plus 1. Okay, so I've got the equation of both straight lines. The first one being 3y equals 5x minus 3, the second one being 3y equals minus x plus 1. I want to find the point intersection between both these straight lines. Now that is a national 5 piece of knowledge. That's just simultaneous equations. Simultaneous equations, when you line them up and eliminate a variable, find out what the other variable is and sub back in to get the second one, you end up with 2 answers. Don't forget that that's got a real life application. That finds the point of intersection of 2 straight lines. So let's line them up. Okay, so 3y equals 5x minus 3. I'm going to call that equation 1. And 3y equals minus x plus 1. I'm going to call that equation 2. Okay, now this is quite easy to get going with. I'm going to obviously eliminate the y's. Now remember that if the signs are the same, you subtract. If the signs are different, you add. Now we can see clearly that that is a positive and that's a positive. The signs are the same, so I'm going to subtract. So I'm going to do 1, take away 2. I could do 2, take away 1, it wouldn't matter. Okay, so 3y minus 3y cancels out to leave me with 0. Now just be careful here. I've got 5x, but it's not 5x minus x, it's 5x minus x, and 5x minus x is 5x plus x, that's 6x. And then I've got minus 3 minus 1, and that's minus 4. Okay, so 0 equals 6x minus 4, let's just turn that round. 6x minus 4 equals 0. Bring that across, change its sign. 6x equals 4 and x equals 4 over 6, which can be simplified down to x equals 2/3. So the point intersection, well, I've got the half of that, I've got the x coordinate, the point intersection is 2 over 3, 2/3. Okay, so my next move is as follows. I need to sub that x equals 2/3 into one of the equations to find the y coordinate. It doesn't matter which one. They both look quite easy, so at random, I'm going to just sub into equation 1. So sub x equals 2/3 into equation 1. So where I see x, I'll replace it with 2/3. That's going to be 3y equals 5 lots of x, but that's 5 lots of 2/3 minus 3. Okay, so 3y equals, okay, so 5 lots of 2/3 is going to be 10/3 then, minus 3. Okay, so I'm going to change 3 into thirds, so that would be 9/3, since 9/3 is equal to 3, and 3y equals 10/3, take away 9/3 is 1/3. Okay, I then bring the 3 down, divide, so I've got 1/3 and I divide into 3 bits, means each bit then is 1/9. So then I communicate my result, point of intersection is 2/3, 1/9. Okay, next question, we've got a triangle which has got vertices a minus 1, 6, b minus 3, minus 2, and c, 5, 2. And part A is going to be to find the equation of the median from C. Okay, so we're looking to find the equation of the median from C. Let's draw in what that would look like. Okay, so the median from C, so it comes from C and it cuts the opposite line in the middle. Okay, so we're going to read point and gradient. Okay, so we've got point already, we can use C as the point. How are we going to find the gradient? Well, let's find the second point here, which will be the midpoint. Okay, so that's going to be the midpoint of AB. So remember the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. Okay, so it's going to be x1 plus x2 over 2 minus 1 plus minus 3 over 2, so it's just minus 1 minus 3 over 2. If you start down here, it doesn't matter, so you might call that one x1, that one x2, it doesn't matter. Okay, so -1 minus 3 over 2, and then y coordinates, that's going to be 6 plus minus 2 over 2, 6 minus 2 over 2. Okay, -1 minus 3 is -4, minus 4 over 2 is -2, 6 minus 2 is 4, 4 over 2 is 2. Okay, let's feed that into the diagram, -2, 2. Okay, I can now find the gradient of the median by doing y2 minus y1 over x2 minus x1. Okay, so that's going to be 2 minus 2 over 5 minus 2. Okay, 2 minus 2 is 0, and it's 0 over 7, which is equal to 0. Now, at that point, that should ring bells. That's telling you that that is definitely a horizontal line. Okay, now if it's a horizontal line, we know that horizontal lines, for their equations, it's just y equals a, where a is where you cut the y-axis. So where do I cut the y-axis? Well, it's easy, just go to the y-coordinate, and we can see it's 2. So it's 2 there, and it's 2 there as expected. Y equals 2. Okay, so remember the horizontal and vertical lines are special cases. That's the equation of the median. Okay, part B. Part B, we're looking to find the equation of the perpendicular bisector of BC. Okay, so the perpendicular bisector of BC, so it's important again to sketch the thing in. So there's BC, so the perpendicular bisector then is going to cut in the middle and at a right angle. Okay, so the first thing that I'm going to go after is the gradient. So I'm going to have to find the gradient of BC and then do m1, m2 equals -1, flip and invert to get the gradient of the perpendicular bisector. That's the blue line. Okay, so gradient BC, that's going to be y2 minus y1 over x2 minus x1, 2 minus 2 over 5 minus 3. Okay, 2 minus 2 is 2 plus 2, that's 4. 5 minus 3 is 5 plus 3, that's 8. Absolutely simplify that down to 1/2. I then must write m1, m2 equals -1. And the perpendicular bisector, then I'm going to flip and invert 1/2. So flip it over, change its sign, -2 over 1, but I'll just write that as -2. Okay, my next move is to find the midpoint. Okay, and that will give me my point that lies in the perpendicular bisector. So I need to go to the midpoint formula. So that's x1 plus x2 over 2, y1 plus y2 over 2. And remember that you need to select the correct 2 points. It's the midpoint of B and C. Okay, so for x coordinates, it's going to be -3 plus 5 over 2. And for the y coordinates, it's going to be -2 plus 2 over 2. Okay, so -3 plus 5 is 2, 2 over 2 is 1, -2 plus 2 is 0, 0 over 2 is 0. Okay, so the midpoint then is 1, 0. Okay, so I've got the gradient and I've got the point, and it's into y minus b equals in bracket x minus a. So that's y minus 0 equals the gradient -2 bracket x minus a, which is 1. That's y equals -2x plus 2. Okay, part C is find the point intersection of both lines. Okay, so it's going to be simultaneous equations again. So the first equation was the equation of the median, and that was just simply y equals 2. The second one was the equation of the perpendicular bisector, and that was y equals -2x plus 2. Okay, so I'm now going to use substitution for that. I already know that the y coordinate of the point intersection was straightforward. It's already definitely going to be 2. Okay, so I need to find the x coordinate. So I'm going to sub y equals 2 into equation 2. So where I see y, I replace it with 2. 2 equals -2x plus 2. Okay, so let's switch that around. -2x plus 2 equals 2. bring that over, change its sign, minus 2x is equal to 2 minus 2, that's 0. And then x equals 0 over minus 2, which is equal to 0. So the point intersection then, final answer is 0, 2. Okay, so now you're going to try one. A triangle PQR, so there's the point P, point Q and point R, has vertices P7, 0, Q minus 3 minus 2 and R minus 1, 8. The median RE. Okay, so there's the median RE. And the altitude QD intersect at the point that we're going to call J. Find the equations of both those straight lines, RE and QD, and then find the coordinates of J. So you're going to find the equations of the two straight lines, line them up for simultaneous equations, and that will get you the point intersection J. Now, don't pay too much attention to where the point looks to be in the diagram. It's just a rough sketch, and have a go.